This question is about the ideal gas. Okay, an ideal gas consists of three dimensional polyatomic molecules, and the temperature is such that only one vibrational mode is excited. Okay, so it's a mono vibrational mode excited structure, and if R denotes the gas constant, then the specific heat at the constant volume of the mole of 1 mole, so specific constant volume of the 1 mole of the gas at this particular temperature. Okay, so here what we have to do, so make 3D gas as molecules has 6 degrees of, with that this has 6 degrees of freedom. At so now if one vibration mode is active at given temperature, so total number of degrees of freedom is will be F equal to 6 plus 2, that is 8. So CV is F by 2 into R, we know the formula, so CV equal to 4R. That's it. So answer to this question is C. Next question, 16. A long solenoid is carrying a time dependent current. So a long solenoid is carrying a time dependent current such that the magnetic field, so this is the solenoid we are talking about, inside the form that Bt equal to B0 T square K hat, where K hat along the axis of the solenoid. The displacement current at the point P on a circle of radius R in a plane perpendicular to the axis. We need to find the basic relationship. Here we actually need the Maxwell's equation. So what happens in the Maxwell equations format, so contour integration ds minus d dt and b ds, or e ds minus d dt b0 t square ds dash. So this is the angular structure, and this will be ID format, and this total value is given as R. So this is a structural form mainly, where contour ds is nothing but the surface area of the cylinder. Now if we proceed, so the tau ds dash is the surface of cross section. So this is the surface of cross section, that is the surface area of the circle. So the finalized structure in this case is E 2 pi R minus d dt of b0 t square pi a square, we are putting the value. So we get that E is directly inversely proportional to R, which is also a time dependent quantity, and the displacement current is ID del E del T. So ID is also inversely proportional to 1 by R, which is the tangential to the surface, which is tangential to the surface, so inversely proportional, and R is tangential. Next one, consider an ensemble of thermodynamic system, each of which characterized by the same number of particles. तो सही में सेम नंबर ऑफ पार्टिकल है थर्मोडायनामिक सिस्टम में, और प्रेशर और टेम्परेचर भी सेम है. सो द थर्मोडायनामिक फंक्शन डिस्क्राइबिंग द एंसेम्बल इज, सो वी नीड टू फाइंड द थर्मोडायनामिक फंक्शन. दिस फंक्शन इज कॉल्ड द गिब्स फंक्शन. H minus Ts. So for a small reasonable reversible process, del GH del H minus T into del S minus S into del T, simple derivative form. So del H equal to T into del S plus V into del P. So del G equal to V into del P minus S into del T. So as constant pressure and temperature, so pressure is not changing, del P is 0 and del T is also 0. So del G equal to also 0, so G is also a constant. Hence we can say that Gibbs is a free energy. So del G equal to 0.